Hello everyone, myself Nithin, and I'm going to talk about Azimuth, which is AstraZeneca's enterprise machine learning platform. I'll start with what is Azimuth and the technologies that are used in Azimuth, and how do we deploy it, and from user's perspective, how do they set up their dev environment, and how do they productionize their application, and architecture of key components like database engine and MLOps, and then tech challenges we faced it, and then finally about Azimuth roadmaps. About myself, I work as an AI platform engineer at AstraZeneca Chennai. Okay, so what is Azimuth? So it's AstraZeneca's internal enterprise machine learning platform, and it's built on Kubernetes with multiple open source technologies and a few licensed tools. And it's been in production for more than 3 years, and it's for end-to-end machine learning platform. So why we built Azimuth? The requirement came from a group called Center for Artificial Intelligence, and there were 3 primary requirements. One is the platform should be cloud agnostic, and then even in POC stages, it should scale from 0 mission, and when the model training is completed, it should automatically tear down to 0 missions. And the platform should support both on-prem as well as cloud. So this is the Azimuth landscape. 3 years ago, we had only 1 component, and now we have this many components. For MLOps, it has 2 components. One is Kubeflow, and other is weights and biases. Kubeflow is the open source machine learning platform, and weights and biases is the licensed one. The project team who uses deep learning PyTorch prefers weights and biases. Coming to secrets, platform team uses Vault to store secrets, whereas users use sealed secrets. And instances, user can spin up spot instances, on-demand instances, and reserved instances. And for governance and security, we use Prometheus, Grafana, and Kyverno. We just started exploring about Kyverno policies and tree scanning. And for IDE, ML engineers prefer VS Code, whereas data analysts prefer Jupyter Lab, and our programmers prefer RStudio. And about the DB engine we built, we used CNPG, Cloud Native Postgres, and PG Vector for vector databases, and Apache Edge for graph databases. And for model training, project team uses PyTorch job, Paddle, and Spark on Kubernetes, and Volcano jobs, Kubeflow, and MPI jobs. And to handle huge volume, we use NetApp FSx, which is good in high throughput and low latency. And for monitoring, we use Grafana, Prometheus, and ELK Kibana logs. And coming to pipelines automation, the data scientists who are comfortable in Python prefers Kubeflow pipelines, whereas AI engineers or MLOps engineers who are comfortable in Kubernetes and YAML manifest prefers Argo workflow. And hyperparameter tuning, project team uses Katib and weights and biases sweep. Coming to CI/CD, we have self-hosted GitHub Actions, and that is used for continuous integration. And for continuous delivery, we use Argo Rollouts. And we recently integrated Argo Rollouts with an extension, which is used for advanced deployment strategy like Canary and Blue-Green. And all these components are installed into vanilla Kubernetes, and it is maintained by separate dedicated team. Okay, how did we deploy Azimuth platform? So we follow GitHub's principle. That is, whatever it is in Git, that will be available in Kubernetes cluster. So here, whenever platform engineer changes something in the GitHub, GitHub action will get triggered, and in the workflow, we use TerraGrunt to deploy ArgoCD application sets. So in order to deploy the same Azimuth stack in multiple Kubernetes cluster, as well as cloud and on-prem, we use ArgoCD application sets. And to deploy few components like Kubeflow, we use remote customize, which means from our local GitHub, it will refer to the remote customized Kubeflow manifest, and then we will patch it as per our requirements. Like instead of pulling the images from Docker Hub, we pull the images from Harbor, and enabling HPA and increasing the replica sets. And to install components like Kubeflow, Volcano Scheduler, we use Helm charts. Okay, coming to application development, the users Here, it is a two-step process. The first step is the user will push the changes into the code, and GitHub action will get triggered. And in the GitHub action, users will build the Docker images, and then they will push the images into the Harbor. And second step is, in the Kubeflow UI, users will pull the images in the workbench. So the advantage of here is, the advantage of building the custom image is quicker dev setup, and the environment will be set same for all the data scientists. Coming to application deployment, so project team uses ArgoCD. So here in GitHub code, we have two sections. The first section contains source code, Docker file, and YAML files. So here, whenever users pushes the changes, continuous integration will get triggered, and in the GitHub actions, users will build the images and then push the images into Harbor. And second section contains a folder called K8s. Inside the K8s, we will have the manifest like deployments, services, and ingress. And whenever there is some changes, ArgoCD will automatically pull the changes from the Kubeflow from this folder, and then it will deploy into Kubernetes cluster, and then it will be delivered to the business users. Okay, we recently built database engine using an operator called CNPG. It stands for Cloud Native Postgres operator. So the intention is, instead of building relational-only databases, vector-only databases, and graph-only databases, so we combined all three as a package using a CNPG extension. And the advantage of CNPG is, it is good in disaster recovery and high availability. So as you can see here, it has 3 pods and 3 services. So the first pod acts as a primary, and the rest act as a standby. So that if primary goes down, the standby will automatically act as a primary, and the automatic backup will happen every week, and then the backup will be stored in S3 buckets. And how did we enable vector database and graph database is via extension. So here we use PG vector for vector databases, and then Apache Edge for graph databases. And by default, CNPG accepts only limited number of connections. So to enhance to maximize the number of connections, we use PG bounces. Okay, and MLOps. So we use Kubeflow and weights and biases. So here Kubeflow acts as a backend, and weights and biases act as a front end. So and to integrate both the tools, we use PyTorch. So here the users, they will start with Workbench. Initial development, they will start with Workbench, and then they will go with training operators like PyTorch, Chop, Paddle, and then to automate all these things, they will use Argo Workflow and Kubeflow pipelines. Okay, about weights and biases. Weights and biases is the MLOps platform, which is used to track and visualize ML experiments, and then to automate the hyperparameter tuning. It has sweeps option, and recently they have introduced a feature called registry. So under registry, there are 3 registry. One is model registry, and then database registry, and then custom registry. So model registry means you can version your model, and then you can track your model, and then you can also you can track the lineage of the model. And second is the database registry, dataset registry, and where you can version your dataset. And third is the custom registry, where you can track your custom configurations. And you can also automate the weights and biases job using a feature called launch. And then they recently introduced a feature called Weave, so where you can monitor, debug, and evaluate your LLM applications. Okay, the tech challenges we faced is we used Kubeflow pipelines with S3 backend. One of the, in Kubeflow pipelines, in the Kubeflow pipelines UI, there is an option called namespace pipeline, but in the backend, it uses a secret called menu ML pipeline menu artifact. So where now user can easily decode the secrets and then get the S3 buckets. And if you get the S3 bucket keys, you can also see the other namespaces logs. So what we did is, in a single S3 bucket, we created multiple folders. Each folder will have a unique keys, and that keys we stored in the secrets, so that even if user decode the secrets, they can see only their respective folder logs. And other challenges we faced is service-to-service communication. So here, CNPG uses service-to-service communication. Like, by default, Kubeflow uses STO and it blocks it. So what we did is we have enabled it via an option called authorization policy, where you can do service-to-service communication through this policy. And the major challenges user faced is workbench restarting. So means that by default, cluster autoscaler will shrink number of nodes when the load is reduced. So in this case, the users uses GPU instances, and while doing some coding, a cluster autoscaler will restart the node because they will just do the Python coding. So during that time, cluster autoscaler will restart the workbench, and that interrupts their work. So what we did is we use Kubeflow pod default, which is kind of webhook. So here we use two approaches. One is we annotated the pod with safe to evict equal to false, and other is PDB, pod disruption budget. So where we set minimum available equal to 1. And other challenges is, so most of the team uses spot instances to avoid cost, but the challenge is, the concern with the spot instances is it is interrupted, as well as we need some configuration. So what we did is we use Spot Ocean. It's a product from NetApp. So here the configuration is very simple. So you can easily configure from the UI itself, and then you just need to select the machines, what machines they need, and then they just need to set the tains. From user's perspective, they will just set the toleration of it. The advantage of Spot instances is it uses machine learning algorithm in such a way it will predict the Spot instances, which will be less interrupted. It actually uses a market score behavior. And coming to container cost allocation, how do we charge to the customers is we use IBM Cloudability tool. So here, we will allocate the namespace to the project team, and whatever cost that is available in the namespace will be charged from the customers, from the users. So you can see the IBM Cloudability tool, it calculates cost even for containers, pods, deployments, and per namespaces also. And the best part is it also calculates idle cost, which means if the container consumes only, if the container consumes 2% of pod, then it is called idle cost. And it also calculates the cost efficiency score. And recently they have introduced a feature called sustainability report, where you can calculate how much consumption you have used it. Okay, and the roadmaps of Azimuth is one of the strategy of AstraZeneca is ambition zero carbon. So we are planning to move the Kubernetes cluster to move to more greener regions and to use lower consumption architecture like ARM-based instances. And we are also planning to enable HPC, high performance computing. So we have decided to use Slurm and Kubernetes. So last month they have open source a framework called Slinky. So we are planning to use that one. And next is Nextflow. So using Nextflow, you can usually switch between Kubernetes and Slurm job. And then we are planning to migrate from SAML to OAuth to authentication and GPU-based runners. And we are waiting for Kubeflow model registry. So I think it's being built by Red Hat team. And alerting systems, like if the Kubeflow pipelines fails and if the workload is less, then we will be alerting to the users. And hardening security using Kyverno policies and tree scanning. And to serve LLM faster, so we are about to use VLLM, which is built on top of page retention. Thank you.